All right. So we're gonna be solving equations and modeling like word problems. I'll do A and C and have you guys try B and D. So we'll kind of trade off a little bit here. So for this one, divide the 20 first. That makes the most sense, right? Don't multiply 20 by 3. I trust you guys won't do that. I expect maybe an Alpha 2 student to do that. You guys are well past that. So don't multiply 20 by 3 because this being the order of operations, clearly 3 is being raised to a power. So you got this equals 27, right? 27 is 3 cubed. We know this. 2x plus 1 equals 3. X will be 1. That totally makes sense. If I plug in 1, all is good, right? Makes sense. I'll do C as well. For C, I'll divide everything by 2. So 4 to the x minus 2 equals 32. Now, unfortunately, 32 is not a power. It's not a clean power 4. You can convert any number to any power you want. I could take 32 like 17 to some power, right? 17 to some power equals 32. Of course I could do that. Why would I do that? That'd be crazy because it's hard to do mentally. But what base can 4 and 32 both share? That can 2, totally. So I can make this 2 squared, then risen to x minus 2 power. And how about the other side? 2 to what power? 5, right? Oh, bless you. So I got 2x minus 4 equals 5. X will be 1/2. No, 9/2. My bad. Thank you, Adi. 9/2. Yeah. I think it makes sense, right? Because 9/2 would be 5/2 squared. That's 2 to the 5th, 3rd. Yeah, totally works. Okay. Okay, I'm gonna pause. Or sorry, I'm gonna freeze my screen. Once you guys work out B and C, let's check in a couple minutes. Here we go. I got 15 and 7/2. Please let me know if you disagree, because I can make mistakes. You get that? 15 and 7/2, guys? And negative stuff. Did I make a mistake? I made a mistake. Thank you for correcting me. Good job. Negative 7/2. My bad. So it should be negative 7/2. That's hard to read that pink. I apologize. Okay. Yes, negative 7/2. That's correct. Yeah, because if you plug in negative 7/2, you get 1.5. Grows 1/2, 1/8. Yeah. Yep. We got. And it'll end up being 1/2. Yep. Yep. Okay. Let's move on, guys. Okay. Now these here are going to be. They still leave an exact form actually, so that's fine. We don't have to. We don't have to use a calculator. So I'll do A and B, then I'll pause and have you guys try C and D. So divide by 5, right? E to the 0.35x equals 4. 0.35x and leave it like that because it's asking for exact form. So no need to do anything crazy here. And then here, divide by 4. And then use a calculator. Just so basically put it in terms of logs, right? 100% correct. Cool. We're good. Okay. All right. I'm going to try C and D now. I'll pause or freeze. Try C and D. We'll check in a couple minutes. Ooh, C is a good one. Yeah, Ron, go ahead.
So I guess so you don't leave it as you don't like solve down on top of it.
Nah, they didn't ask to. No. Hey guys, treat part C like a quadratic. Maybe let like a arbitrary letter like A equal 3 to the x. That might work. Here you go, guys. And actually, let me circle. Okay. So we see something like this here, 3x to 2x, but I can't combine those necessarily because it's kind of like unlike terms. But you could let some random letter like A or whatever, B, C, D, I don't care, equal 3 to the x, treat like a quadratic, because clearly this term is that squared, right? So A squared minus 2A minus 3 is really simple factor. After you factor it, you bring 3 to the x back into the whole, and of course that's log base 37. 3x can't equal a negative number because how can you raise 3 to the power of the negative? Positive can't be negative. So that's no solution for that one. So the answer only answers this one here. Here, just multiply both sides by the denominator. I would not distribute that. I think it makes it more complicated. Divide by 12. That's 5/3. I think that right. Yeah, both back and 4. And then subtract the 1. And then divide by 4. And then do a log. So we have log base 0.7 of 1/6. So the algebra is a little bit more intense with C and D. Ask questions. Any questions so far about C or D? We're good? We're cool? I'll just give you guys a little more time to copy it down before we do the log equations. But yeah, that's probably as complex as the exponential equations will get. Yeah. So yeah, just a little bit more creativity required with definitely for C. You gotta be very creative there. Okay, we're good? All right, let's keep moving, guys. Let's look at B. Let's look at all these here for part B. So just remember what you do with logs, how things move around. It shouldn't be that hard. Again, I'll do 2 of these and I'll have you guys try 2. So for part A, that's easy. Log base 3 of x plus 5 equals 4. X plus 5 equals what to what power? Yep, which is 81. X plus 5 equals 81. X equals 76. For C, you can use the log property, right? Right, you have this luxury to do that. And also using another property on the right side, moving the 2 to the back, so rolling it back along the log. Now, what happens to the LNs on each side? Yeah, they pretty much cancel, or you could just say this, right? You know, because they're both the same kind of log on each side. Negative 5x, yeah. You get this, right? And I think that's factorable. That's what, 2x, x, let me think here. However, we have an extraneous solution, guys. Which one's extraneous? Which one would fail? Yeah, the 1/2 fails. Because you can't log negative numbers, right? So if I yeah, if I plug in, come on, here we go. Yeah, if I plug in 1/2 into either one, I'm getting a log of a negative for the second log on the left side of that equation. That's not gonna be good. So you gotta look for extraneous solutions. So definitely cool. All right, go and try part B and D. I'll pause. We'll check in just a sec. Oh, B is too easy. That's not a test problem. That is way too easy. So always check for extraneous. How about the whole test like that? Okay, if the Niners win the Super Bowl, I'll write you guys the easiest test in the world. No, I'm just kidding.
What about, if Niners play well?
The Niners score.
CMC wants 2 touchdowns.
He will. I'm calling it. He will get 2 touchdowns. Christian McCaffrey.
Offensive player, yeah.
The whole Lamar Jackson thing is total BS. It's like just might as well call it the best player from weeks 13 to 17. Don't call it the regular season MVP winner. It's like literally he was not the best player throughout the whole season. Purdy was way more consistent. He had one bad game, which was on national TV against Christmas against Baltimore. But yeah, I just think that was how Dak Prescott second. That doesn't make any sense either. So
Really crazy if CMC took home bowl.
So, it's weird. They usually don't do that. It's such a weird way it's voted on. Usually, yeah, usually. Here we go, guys. So yeah, this one's easy. That's 2. These are super easy. For D, you have to use a quotient property, which is x over x plus 1. Then you raise it to the e power to e squared. Then I cross multiply e squared times x plus 1. So that's all terms of x on one side, which would be ex squared minus x, and then you have negative e squared. Ooh, negative. That's a negative. It's a negative right there. My bad. My apologies. Easy fix. You might be right, actually. Hold on a sec. Yeah. This is the solution, you're right.
Wait, are you not supposed to calculate what your score is?
No, you don't have to evaluate, it's fine. Yeah, because you can't log negatives, yeah. Right. Yeah, right. Yeah, it's gonna be no solution, guys. Because you wind up getting an answer that's negative when you isolate X, so not cool. Okay, we're cool? We're good? All right, let's keep going. That's base 10, guys. Which one? Sorry. Guys, quiet, please. Guys, we're still working. Yeah, it should be 5, yeah. Hold on, guys. Let's actually work out its entirety. Yeah, so the answer is just 5, not -4, right? But you do want to show it all being worked out. Because 10 to 0 times 1. Yeah, I mean, yeah, if you look at 5 makes sense, right? But yeah. So that's another problem that involves logs. Okay. Any questions so far? We're halfway through the notes. We're good? Questions now? Okay, let's keep moving. All right. This I like a lot. This is actually a really cool model. Let me just zoom out a tad. Here we go. Okay, this print is kind of small, my apologies. So, guys, quiet. So we've looked at exponential models, right? But exponential models are not terribly accurate because it assumes that it just goes up forever, right? And that usually doesn't happen in real life. Like, for example, let's say we're looking at like COVID infection rates or just people getting the flu. Ultimately, like, let's say it's spreading exponentially at the school, like everyone's getting sick, right? Let's say Arya comes here sick, gets all sick, right? Then everyone gets other people sick, right? But ultimately, we get to a point where the whole school's sick, and that's it. We've reached our capacity, right? So logistic growth models are actually more accurate in that result, in that regard. Now the equation can be written in kind of a few different ways. So I'm going to cheat and pull up the key for this. Actually, I don't have the key for this. Okay, give me 1 sec here. I'll have to look up the key because this equation can be a little bit intense. 1 sec here, guys. Never mind. Yeah, I'll look at the formula. Here we go, guys. Okay, guys, quiet. Guys, quiet, please. Thank you. I think I've done this right. Let me I'm a little rusty with the logistic growth. Well, that's one way of writing it. That's not what I prefer. You know, let's go with what yeah, let's go with the one with E, I guess. That's fine. Okay. Let me change up a little bit. Actually, one last thing I'm gonna do. Hold on 1 sec, guys. I got another resource here. I should have been better prepared. My apologies. Here we go. Chapter 3. Test study guide. Yeah, no, I was right. Okay. Okay. All right. I know what's up. All right. I'm not totally lost here. All right, we'll go with what I put because I like that a little better. Okay, so here let's fill out more of this, guys. So C is called the not the limiting capacity. There's a term for it.
1 plus cosec from
The 1 plus ABX. You know what, guys? Let me do this. Hold on. No. Let me expand it. No, my handwriting. C over 1 plus. There we go. Is that better? Okay. So C is kind of like the what do we call C? It's called like the limiting capacity or something. There's a certain term for it.
The limit, maybe.
Yeah, okay, limiting capacity. Yeah, okay. I gotta have more faith in myself, guys. I'm sorry. Yeah, I know, right? Thank you. And that's because Y approaches C as X approaches infinity. And B, just so you know, B will be between 0 and 1. So B is a number between 0 and 1. So yeah, so what happens is that when this gets risen to a big power, that pretty much becomes 0, right? Right? Because if you have a fraction of your base here, and that as part of this formula, we get percent B is between 0 and 1. What happens is that goes towards 0, so you have C over 1, so you have Y equals C. So that's why it's called limited capacity. So for example, let's say I have like 800 people on this campus, we have like 650 students, 150 adult members, right? Yeah, if someone comes here with like the flu, ultimately the limited capacity is 800 people get the flu, right? Well, let's say we're all like in lockdown and we can't leave this campus. Eventually everyone's gonna get sick, right? So that's one way to think about it. The Y-intercept, you plug in 0 for X. Y will equal C over 1 plus A. That's the breezy. So that's Y-intercept. C over 1 plus A. That's what this is over here. Okay. Let's keep moving here. I'll show you. We'll model in a little bit. We'll do a problem like that. We'll get there. Using analytical methods for this, the maximum growth. I already showed you guys what happened here. Basically, Y equals C when X approaches infinity. I already kind of showed that to you guys. So, and another thing to keep in mind, there are 2 horizontal asymptotes. That I do know. And turn value of X if X equals C over 2. So in this case, C's cancel on each side. Or 2 equals 1 equals. In order for that to be true, 1 over A, X will be log base B. If you really want to kind of get a little crazy with the math there, that's what happened. Okay. Does that make sense, what I just did? I set the logistic function equal to C over 2. Drop the C's. The denominators have to be the same. Solve for, try to isolate X the best I could, which I did. So, yeah, all right, good.
What are the horizontal asymptotes?
Right here.
As X goes towards negative infinity, just go towards zero, it's gonna happen to get you a bar. That's gonna be a fraction, so it's just gonna get really large. What are those? That's C.
Yeah, that's C, guys, up here. That's C. Yeah, Catherine, go ahead.
Just.
Exactly. Eventually we have to cap, we have to top, hit a cap. All right, so here we go, guys. So this is another way of writing it too. So an alternative way of writing it. Alternative formula for logistic growth. Is this y equals C over 1 plus A
That's another alternative you can do. Now, E is not between 0 and 1, we know this. But it becomes the K, why does this become the K? You're raising to what power? So then it becomes the K afterwards. So it's still the same kind of effect. It's a little different way of writing it. So that's yet another way.
That actually is the more common way, I suppose. But the way I've taught in the past was with the ABX. But let's do what they have here, just to be consistent. So determine initial population, that's when t equals 0. That's easy. Y equals 50 over 1 plus 9 times e to the 0 power. 50 over 10, 5, right? Carrying capacity is 50. That's easy. Algebra return time when the maximum growth of the population occurs. Well, oh, the maximum growth. Okay. Shoot. Yeah, I messed up, guys. The maximum growth occurs. Crap. I really messed up, guys. Okay, let me move this off to the side here. Okay, coming back here again. On the previous page, my apologies. The maximum growth occurs right there. Yeah, because that's the biggest rate of change. Yeah, my apologies. I was correct with C, what I said about that, but it occurs when f of x equals C of 2, equals that. Or when we reach half the capacity. Because see how that's the steepest change right there? Yeah, my apologies. That's what's happened there. We're going to be talking about things called derivatives later in the spring. That's the slope of the tangent line. That's where you have the steepest slope. That's when you're going to see the biggest acceleration. That's when all of a sudden you notice people getting sick, right? Like, oh wow, now like Aria comes to school again. He gets like these 3 guys sick, then I get sick, and then you guys get sick. And then after a few days, like, oh crap, like now it just seems so rampant. And then you reach the limiting capacity at some point. So sorry, that's what's meant by that. My apologies. Now, let me erase this stuff here. Hold on, what's that, guys? Whoa, what am I doing? Okay. All right, let me resize that. Let me do this over again. I really messed this one up. I'll do it over again really quickly. So here we go, guys. Initial population, t equals 0. It's 5. That's 50. Then you can do 25 equals 50 over this. So then 1/2. Subtract the 1. Negative 1/18. Am I wrong? C over 2, right? Did I do something wrong? Right.
Still at the bottom, so it's 1/2 equals 1 over 1 plus 9.
Yeah, same thing. Oh, 1 over. Oh, you're right. You're right. You're right. Something was off. Yeah. Well, I would have discovered it, but thank you for letting me know in advance because something would have been really weird. Thank you, guys. I appreciate it. All right. So then 2 equals. All right. You guys feel better now? Good. I feel better too. All right. Yeah. Yeah. Because I can't log a negative number. That was going to happen eventually. T equals natural log of negative 1/9, I think. No. Hold on. Negative t. And now we work that out. You get 2.197. This is days or months? Months. There we go. That's what sees its fastest growth. Okay. Let's try another one here. Yeah, all right, good.
Is it possible for the graph to, instead of
Mhm.
being like this, to be like a sideways?
No, because it would not be a function then. It would fail the vertical line test. Right? I know, right? Thanks. All right. Okay. All right. So so this is now looking at the flu, right? And spreads like this, right? So 5,000 is the capacity because that's the most students you have on the campus. You got this stuff here. So how many students are infected after 5 days? That's not hard. Just do 5,000 over 1 plus 5,000 divided by that's -4, I think. Yeah, you get about 54 kids. Usually round to the nearest whole number or round down. I'll tell you how to round it on the test. Now, we'll cancel classes when 40% more students are infected. So 40%, you got to do 0.4 of 5,000. Okay. You got to cross multiply and work it out. I'm gonna kind of do this quickly. You should get shoot. Hold on. Never mind. I'm not gonna skip steps. There's too much going on here. Let me erase the top. Um, bless you. Bless you. Do you guys get 10? Yeah, it takes about 10 days. Yeah. Now, yes, you could have graphed it or gone to Desmos, but I want you guys to do the algebra because I will actually force you guys to do that because I want to see the algebra. So that's the algebra you have to show. Yeah, I knew I couldn't skip steps. I kind of hesitated, like, yeah, there's like 5 or 6 steps that I'm not going to do in my head. Yeah, it's 1 over 0.4 on this side here. Okay, any questions, guys, on this one? No? We're good? Okay, cool. Okay, last bit of stuff here. These are really cool problems. I like the Richter scale one because we tend to have earthquakes here. So Richter scale uses logs. I sub 0 is 1, meaning that's like kind of like the minimum intensity, like the slightest move. I mean, the Earth's always moving, obviously, but kind of the slightest earthquake you could feel, I guess, is that. And so I is like relative to that slightest earthquake you can feel. So, like for example, we had a 7-point earthquake back in 1989. That's when the Giants were playing the A's in the World Series. I was actually in middle school when that happened. We haven't had an earthquake that big in a long time. But to go from a 6 to a 7 is a big jump, right? That's it's actually a tenfold jump because you're doing log base 10. So when they say, oh, an 8-point earthquake, that is crazy, right? Because that's way more intense than a 6-point. That's 100 times more intense than a 6-point earthquake. In a 6-point earthquake, we would feel it for sure. 8.0, like, just say your prayers. That's best thing I tell you. Let's pray that never happens. So in 2014, Edgefield, South Carolina experienced an earthquake of 4.1. In 2014, Nagato, Japan, experienced an earthquake that measured 6.5. Find the intensity of each earthquake. So you're going to do 4.1 equals log base 10 of I over 1. So the intensity is just 10 to the 4.1 power. For Japan, it's going to be this. Log base 10 of I. So if we do 10 raised to 4.1 power, that's the intensity. I don't know what the units are for this, but that'd be the intensity. But it's a 6.5. Yikes. Divide that by the previous one. It's over 250 times more intense, which is really scary. I guess they use a Richter scale because just to make it easier for people to comprehend, like, hey, like a 5.0, 4.0, whatever. And you say it's 10 times much because it's using base 10 for log. So, but yeah, that's how you would compare it. Ryan, good.
I guess, so what is the formula, like, isn't it just kind of 10 to the power of 11?
Yeah, totally. Yep, exactly. I was just kind of just doing it like kind of piecemeal so you can see exactly what's happening. But ultimately, you just do this. You do 10. Yeah, ultimately, what you would do is you would say 10 to the I2 over 10 to the I1 if you call I2 and I1. But then you can actually combine it like this. So if you take the difference in the Richter scales and do 10 to that power, that's what that would tell you, right? So if I do 10 to the 2.4 power, I will get that. Yeah, 10 raised to 2.4 power. Yep, I would get that. So that's a quick and easy way to do it. Okay, last one here, Newton's law of cooling. This is actually a really cool formula. I like this one a lot. This does show up on AP Calculus quite a bit. You don't have to know the formula. I'll give that to you. Don't worry. But if you think about what this represents, Tm is the temperature of the medium, like the temperature of the environment, right? T0 is the initial temperature, and T is the temperature at a particular time. So, for example, I have like, the thing of hot tea here, right? Maybe it was at 100 degrees Celsius, so it was boiling, right? Or 212 Fahrenheit, if you want to think of it like that. But the room is about 60 degrees Fahrenheit, right? Or 60 or 70 degrees Fahrenheit. Actually, it's 70 degrees Fahrenheit right now. So if I brought some hot tea from downstairs, those little tea kettle, it's gonna be at close to 200 degrees Fahrenheit, so it's gonna be scalding hot. 70 degrees in the room. After some time passes, because I have this out in the open, it's gonna cool down, right? Even with the lid on, it still has to cool down a little bit, just slows down the cooling. But this is a form that's used when you have surrounding air or water as your medium. And of course, little t is time. K is a constant we'll have to solve for. And the constant is kind of dependent upon the material or the substance you're working with, like in this case, hot water and the air, right? The air around us. And this could change, by the way, for different elevations. That could also change too. That's also something to think about as well. Especially because like water boils, a little bit longer when you're at higher elevation. So anyway, you're working at a coffee shop, want to serve the coffee only after its temperature is 95 degrees Fahrenheit because customer will be really happy. We said won't be happy because it's too hot. After brewing it, the temperature of the coffee is 212 Fahrenheit. You'll sit in a room that's the ambient temperature 75 degrees Fahrenheit. After 5 minutes, it cools down to 150. How long will the coffee have to sit before you can actually serve it to your customer? Okay. Well, you just serve it anyway, but whatever. It's fine. So here's what we're gonna do. Tm, the medium, is 75 degrees. That's the medium. T0, the initial temperature, is 212. Actually, we'll say 150 because you're starting at 150, right? Or actually, you know what? Let's do 212. That's fine. Let's do 212. T is 150. Capital T, by the way. Or actually, let me take it back. Capital T, T of 5. That's a function notation, by the way. Equals 150. And little t is 5. There we go. Got to solve for K, yes. So 150 equals the medium plus initial temperature minus the medium again times E K 5. Work it out. What's that going to be? 137, I think. Am I correct in saying that? Oh, all right. Well, I'll finish out the video. Go off to advisory. Wow, I usually do finish. I took a little too long there. That's what I messed up. Yeah, this last page. You guys know what the homework is? Just give me homework 10. I'm gonna finish up right now.
No, I know, that was my fault. I feel like I feel like we have like a full answer. Yeah. Your brother asked me. No, it's not true. I'm gonna study it. I'm doing
You get 11 for Tuesday.
I like that.
It's 111 all, because there's 25.
There is.
Like.
Oh, I forgot to buy 5. Crap. Gosh darn it.
Thank you.
See you guys. Man. So K is actually negative 0.12.
You know why? Use it. I don't know. It's probably. Why intersect the other IC?
Yeah, okay, I got it now.
You push him. It's like good because I haven't tapped it. Just trying to look at it.
There we go. Takes about 60 minutes, guys. Okay, there we go.
Thank you.